Hello everyone! In this tutorial, we will create a composite bridge from scratch using AutoBRIDGE. We start by creating a metric bridge template adaptive family and build the workflow step by step. First, we define the primary reference planes for the asphalt layer, structural slab, and the left and right deck edges.
Next, we add instance parameters to control deck edges, then asphalt thickness, slab thickness,
We begin by defining parameters for the right and left deck edges.
The asphalt thickness parameter controls the vertical offset between the alignment insertion point and the top of the structural slab. The slab thickness parameter then defines the depth of the structural slab itself. Finally, the haunch reference plane defines the insertion level of all girders, representing the vertical offset between the girder top flange and the slab soffit.
At this stage, all parameters are structured clearly for full parametric control.
Now we move to a critical step by placing 3 reference points along the center vertical reference plane. These reference points define the control lines for the asphalt surface, the top and bottom of the structural slab, and the girder reference level, all driven by a rotation angle parameter.
We set all points to always visible and constrain them relative to the center reference plane. A rotation parameter is assigned to each point to control deck superelevation. For each adaptive point, we set the work plane on the point and create a reference line aligned to its center. Changing the rotation parameter simulates superelevation by rotating all reference lines. Next, we align the endpoints of the reference lines to the left and right deck edges. All lines are then converted into reference lines. At each step, we validate the parametric behavior to ensure model stability. We then define reference planes for girder layout and assign edge offsets. For simplicity, we use shared parameters for both sides, though independent control is possible. The girders are distributed using equal spacing across the deck width.
We place reference points on the girder reference lines and set them as driven points. Each point is constrained by intersecting with the girder spacing reference planes. These driven intersection points define the hosting locations for all girders. Each reference point represents a girder insertion location. Toggle each reference point to present each point face vertically.
We verify that all points respond correctly to superelevation and deck width changes. Next, we create the girder family. We save the main family and open a new generic model adaptive family for the girder. Reference planes are created to define girder geometry, including top and bottom flanges. Parameters are assigned for top flange width. Then we define bottom flange width and overall girder depth. Model lines are used to construct the girder section, including flanges and web. Geometry is completed using clean line connections. A dedicated subcategory is created for the girder for visibility control. Ensure the family is set to always vertical and shared is disabled.
Load the girder family into the host family and placed at the reference points created before.
We continuously test superelevation and deck width behavior. Next, we define parameters for girder depth and haunch thickness.
As you can see, I am adding points on the reference lines at the top of girders to make the shape of haunch, to create a one-shape boundary of slab. Now I'm creating the slab boundary subcategory. To do this, head to the Manage tab, open Object Styles, and add the new subcategory under Generic Models. Once that's set, I'll use the Spline tool to connect the points and define the boundary.
We verify super elevation, deck width, and girder parameters. The model is tested for consistency and parametric stability. The family is saved and loaded into AutoBRIDGE.
Now, within the Family Manager tab, click the Add button and select the composite family to integrate it into AutoBRIDGE. Once the family is loaded, head over to the corridor section and click on Civil 3D. Select the appropriate alignment and profile for your project. In the Section Family dropdown, pick the Composite Family and specify the Solid subcategory. Moving to the Chainages tab, choose your desired stations and then hit Run to generate the model. Now, let's take a look and verify the generated model. We'll inspect the geometry to ensure everything has been placed correctly according to our alignment and profile. Thanks for watching. If you found this workflow helpful, feel free to reach out with any questions. I'll see you in the next tutorial.